Hello, good day. For this video, we're going to discuss about limiting a reactant and an excess reactant. So before we proceed to the actual procedure of the computation, let me give you an example on how to analyze the limiting and excess reactant. So let us try to adopt the chemical reaction into a world of food sa world natin, for example. So, for us to have a one cheeseburger, so kailangan natin magkaroon ng reactant na isang bun, isang cheese, and isang meat. And that gives us a product of one cheeseburger. So from this, let us give an example of this as an equation. So for us to have a one cheeseburger, ito yung kailangan natin. Isang bun, isang cheese, at isang meat. Now, I have, in our refrigerator, ito yung nakita natin. For example, we have 3 buns, 9 pieces of cheese, and 3 meats. So the question is, how many cheeseburger can we make if we have this kind of ingredients? So if we try to just look at it, obviously we have 3 buns and 3 meat, and we also need a 3 pieces of cheese. So if we need a 3 pieces of cheese, we're going to have minus 3. Kunin na natin yung tatlong buns, kunin na natin yung tatlong cheese, at kunin na natin yung tatlong meat. Now, 0 na si meat, 0 na rin si buns. But we still have how many cheese? We have still, how many? 6. Tama ba? We have still 6 cheese. So, from these ingredients, we can see what is the limiting reactant. So when we say limiting reactant, it is the reactant in a chemical equation or reaction that limits the amount of the product that can be formed. So in Tagalog, ibig sabihin, ito yung dahilan, ito yung nagiging nauunang nauubos at nagiging dahilan kung bakit naglilimit yung reaction, nag-i-stop yung reaction. Like this one, we have this kind of ingredients sa ref, and dahil wala ng buns at wala ng meat, hindi na tayo makapag-produce pa ng cheeseburger. Kasi ang kailangan sa isang cheeseburger, isang bun, isang cheese, isang meat for us to have a cheeseburger. So dahil naubos na yung meat at buns, these two serve as the limiting reactant or the LR. We call it limiting reactant, si buns, tsaka si meat. Now, the excess reactant o yung sobra from the equation or from the reaction is the cheese. We still have 6 pieces of cheese. Now, pwede ba tayong gumawa ng cheeseburger out of this 6 cheese? So, obviously, not. Kasi, stop na. Wala ng buns, wala ng meat, wala tayong magagawang cheeseburger. And that have the limiting and excess. Or by the way, the excess reactant is the reactant in a chemical reaction that remains when a reaction stops when the limiting reactant is completely consumed. So obviously, kahit nag-stop siya, nagre-remain siya doon. But still, hindi siya makakapag-produce ng new product kasi stop na siya. Hindi na siya makakapag-produce without the help of the other. So that is the limiting and the excess reactant. So let us try to adapt this problem into our problem setting in our module. So we have this example. Sorry. So we have this example. So the problem is, what is the limiting reagent? Reagent or reactant is the same, by the way. If we start with 2.80 grams of aluminum and 4.25 grams of chlorine gas, 2.80 and 4.25. So from this, we have also given the balance equation. 2 aluminum react with 3 molecules of fluorine gas, so yields to 2 molecules of aluminum chloride. So from this, so check if first if it is balanced. So 2 aluminum, 3 chlorine, 6 chlorine gas, that precedes the 6 chlorine gas. So from this, after checking if we have if it is balanced, next, since the problem since the problem is in grams. Lagi kong sinasabi, ang gagawin natin pag iyan ay nasa grams, ano pong gagawin? So, obviously, we need to convert from grams to moles. So, remember our computation from grams to moles. So, we need to divide by its what? We need to divide by its chemical or atomic weight. So, let's have first, yan yung ano natin. So, meron tayong aluminum and chlorine. So, convert muna natin. Sabi dito sa problem, meron tayong 2.80 grams ng aluminum tsaka 4.25 grams of chlorine gas. Ngayon, hahanapin natin yung limiting reactant or limiting reagent. Sino yung unang maglilimit sa reaction na to? Okay? So, ito yung dalawang given natin. So, unahin natin si 2.80. We have 2.80 grams of aluminum. So, we need to convert it from grams to moles, as I said. So, we need to divide, nasa baba. So, in every 1 mole of aluminum, meron tayo. So, ano yung atomic weight ni aluminum? So, we have 26.98. So, we have 26.98 grams. So, from this, 2.80 divided by 26.98 grams of aluminum. So, cancel na natin si grams, mariremain si mole. So, we will have the answer of 0.10 mole of aluminum. So, but in our book, I have given you the scientific notation where we come up with 1.04 times 10 raised to negative 1. Okay, it's okay lang din po yan. So, from this, next, si chlorine gas na natin. We have 4.25 grams of chlorine gas. So, in every 1 mole ng chlorine gas, meron tayong 70.9 grams. So, equals. Bakit 70.9? Kasi chlorine have atomic weight of 35.45 times 2. So, yan yung ating sagot. So, 4.25 divided by 70.9. So, we will have the answer of 0.06 mole of chlorine gas. Ito canceled out na kaya naging mole na tayo. Then, in our module, I have given you also the scientific notation of 5.99 times 10 raised to negative 2. Okay? So, from these two, dahil gagamitin nga natin mole, ito yung gagamitin natin. We will serve this as basis for our computing the limiting reactant. So, next. So, in our book, kasi ginamit niya ratio. So, let me show you another way. Conversion factor style na ang gagawin natin. So, kunin muna natin first, i-set aside ko na yung problem ha. Si 2.80 or yung kukunin natin obviously is 0.10 mole of aluminum. So, if we have 0.10 mole of aluminum, kung ito ang gagamitin natin, so we need to know what will be the reaction of aluminum to chlorine gas. So, from this, conversion factor tayo. So, sa taas, kukunin natin yung number of coefficient sa balance equation ni chlorine gas kasi hanapin natin kung kung ilan yung magiging reaction na makukuha natin. So we have 3. So sa ibabaw natin si 3 which is yun yung ating ini-aim para makuha natin. We have 3 chlorine at sa baba ay si aluminum. And what is the coefficient of aluminum? We have 2. So, from this, 0.10 mole of aluminum multiplied by 3 divided by 2. So, we will have the answer of 0.15 mole of what? So, dahil cancelled na si aluminum, matitira ay, syempre, si chlorine gas. Okay. So, ibig sabihin, pag ginamit natin si 0.10 mole ng aluminum, kailangan meron din tayong 0.15 mole of chlorine gas. Okay? So, mamaya natin i-analyze. Next, let's go with the second one. We have yung sa 4.25. So, gamitin natin si mole. So, we have 0.06 mole of chlorine gas. So, syempre sa taas yung ating gustong i-convert, which is aluminum. So, ang ating coefficient is 2 at ang sa baba ay si chlorine. So, 0.06 times 2 divided by 3. So, we will have this answer of 0.04 mole of, dahil cancel na si chlorine, aluminum. Now, let us try to, set aside ko na to. Let us try to analyze the answer. So, from this equation, ayan, itatapat ko yung ating balance equation. So, hinahanap natin yung limiting reactant with this problem. So, by this equation. So, if we use 0.10 mole of aluminum, so, kailangan natin ng 0.15 mole of chlorine. So, let us check kung ang 0.15, meron ba tayong 0.15 mole ng chlorine? Meron ba ng chlorine? So, obviously not. Kasi ang answer, meron lang tayo dapat ay 0.06 mole of chlorine gas from the 4.25 grams ng chlorine na given sa ating problem. So, obviously not. So, obviously, this equation is not gonna proceed kasi mas madami yung kailangan nating chlorine na wala naman tayo. Okay? How about this second one? This second one. So, we have 0.06. So, 0.06 mole of chlorine gas. So, pag ginamit natin ang lahat ng 0.06 mole of chlorine gas, ang kailangan natin na aluminum ay 0.04 mole of aluminum. Let us check. Ang 0.04, kaya ba ng aluminum? Obviously, yes, because meron tayong 0.10 mole of aluminum. So, sa mga nalilito, uulitin ko, itong equation na to, kinonvert natin yung given na itong 2.80 grams of aluminum tsaka 4.25 grams of chlorine gas from our problem. So, kinonvert natin siya from grams to mole, kaya dito tayo nagbe-base kasi nasa mole factor na tayo. So, kaya ito ang tinitignan natin. So, kumbaga, ito yung laman ng ref natin o yung laman ito yung ingredients natin. So, meron tayong 0.10 mole of aluminum at meron din tayong 0.06 mole of chlorine gas. So, from this, dito sa computation na to, ang magagamit natin is lahat ng chlorine gas na 0.06 mole of chlorine gas at ang magagamit naman natin o ang kakailanganin natin from this ratio is 0.04 mole of aluminum, which is kayang i-provide ni aluminum kasi meron tayong 0.10. So, by this problem, ito yung check. Ito yung gagamitin natin. So, by this problem, we can identify that the limiting reactant is what? So, ang limiting reactant natin ay si chlorine gas. Tama? Kasi siya yung ini-use up natin lahat. At siya yung reason bakit maglilimit yung reaction, magi-stop yung reaction. While ang ating excess reactant, yung sobra, yung natira. Kumbaga. So, ang ating excess reactant from this equation is the aluminum. Now, next question. How many excess reactant? So, simply by subtraction, 0.10 mole minus 0.04 mole. So, we will have the answer of 0.06 mole ng aluminum. So, ito yung ating excess reactant. So, that concludes that will be the answer for limiting reactant for our first example on our book. So, yung sa book medyo yung iba sigurado nalilito kasi finding ratio agad. So, ito pwede nyo gawin. So, trial and error ang gagawin natin. So, let us have another sample. Let us have this. Ayan, medyo mahaba-haba. Ma'am, mahaba-haba po. Okay, pero simple lang yun. So, let's have this problem. Sabi dito, what is the greatest amount of ammonia? Ay, sorry. Nilipad. Sorry, nilipad. So what is the greatest amount of ammonia in moles that can be made with 3.2 moles of nitrogen gas and 5.4 moles of hydrogen gas, which is the limiting reactant, which is reactant in excess or the excess reactant, and how many moles of it are left over. So, tinanong yung leftover dito. So, let us try to compute for it. So, dahil naka-moles na siya, okay, so dahil naka-moles na siya, we don't need to convert the given from moles, from grams to moles kasi given na siya si moles. So, simply, by just computing ano yung magiging limiting reactant. So by the way, this is the balance equation. So first, laging check kung balance. So we have 2 nitrogen, 6 hydrogen. So it will balance. So from this, first, given natin, we have 3.2 moles of nitrogen gas at 5.4 moles of hydrogen gas. So let us try to compute first for the 3.2 moles. If we use all of the 3.2 moles of nitrogen gas, so i-convert natin. So ilang moles kaya magre-react para magkaroon tayo ng hydrogen gas. So, sa taas si hydrogen gas. So, we have 3 molecules of hydrogen gas at sa baba si nitrogen. So, obviously, serve as 1 kasi sabi ko pag wala. So, 3.2 times 3 divided 1. So, we will have the answer of 9.6 mole, cancel si nitrogen, cancel si of hydrogen gas. Okay. Ngayon, pag ang gagamitin naman natin ay 5.4 moles. 5.4 moles of hydrogen gas. Ilang nitrogen gas naman yung gagamitin natin? So, sa taas natin yung nitrogen gas, which is 1, coefficient ng 1, and sa baba natin is yung 3 hydrogen gas. So, para ma-cancel out sa hydrogen gas. So, 5.4 divided by 3, so we will have the 1.8 mole of nitrogen gas. Now, let us try to identify. Kasi tapos na agad eh. Ito na yun eh. Kanina kasi medyo mahaba dahil nag-convert pa tayo from grams to mole. So, try ko lang kunin yung yung balance equation para masulatan natin. So, this will be our balance equation. Nitrogen gas, F3H2 yields to 2NH3 ammonia. Okay, let's have this one, balance. So, if we use this one, yung first equation natin, so, ginamit natin lahat ng given natin na which is 3.2 mole, 3.2 mole of nitrogen gas. Now, para maggamit natin si nitrogen gas, para mag-react siya with hydrogen gas, kailangan natin ng 9.6 mole ng hydrogen gas. At dito naman sa pangalawa, ilalagay ko sa baba. Kung gagamitin natin lahat ng hydrogen gas, ang kailangan natin ay, syempre, yung given which is 5.4 at ang kailangan naman natin sa nitrogen gas is 1.8. Now, let us try to analyze kung alin sa kanila yung papasok sa given natin. Okay. So, try natin yung umpisa. So, 3.2 mole of nitrogen. So, yes, use up natin lahat yung nitrogen gas. Tama ba? Now, para magamit natin to, kailangan din natin ng 5.4 moles of hydrogen gas. So, pwede ba? Pwede ba yung 9.6 sa 5.4? Obviously, hindi ma'am. Kasi, ang meron lang tayo sa ating ingredient o sa ating given ay 5.4 lang. Pero, ang kailangan natin ay 9.6. So, obviously, this reaction is canceled. Hindi pwede to. Walang mangyari. So, check natin yung pangalawa. Si hydrogen gas ay meron tayong 5.4. Tama ba? Ginamit natin lahat ng hydrogen gas. At para magamit natin lahat yon, ang kailangan naman para mag-react siya is 1.8 moles ng nitrogen. So, pasok ba? Yes. So, itong equation ang gagamitin natin. So, meaning yung pangalawang equation, ito po ang gagamitin natin. So, from this, we can identify which is the limiting reactant. So, LR na lang susulat ko ah. Limiting reactant is the hydrogen gas since ginamit nating lahat yung given na 5.4 moles. Ito, given. Ito, 5.4. Ito, 5. Now, ang ating excess reactant naman or ER is the nitrogen gas. Now, may isang question kasi, how many moles are left over? Ilan yung sobra? So, just simply do the subtraction. So, ang given natin for nitrogen gas is 3.2. So, 3.2 mole. So, minus natin dun sa makakapag-react with 5.4. So, 3.2 minus 1.8. So, we will have 1.4 mole of nitrogen. And this will be the excess or leftover. Okay? And that is how to compute a limiting reactant. So, you just do the conversion factor pag kaya nyo to, pero pag hindi, do the ratio, yung just like what we have in the module. So, trial and error, walang malilito, especially if we are going to convert from grams to mole. Okay? So, check first if it is balanced, then, double check the computation. Okay? So, now, yan po ang ating limiting reactant. So, I hope you understand the discussion for a short while. Then good luck. So for this week, ito lang yung lesson natin. Then we check for the uh following information we have in our GC. Okay? So God bless.